Alright, guys, today we're going to talk about inheritance. So, first things first, I'm just going to press run on my little file here, which just spits out inheritance so far. So, next thing next, I'm going to look at the UML diagram for what I'm about to make. So, I have here my UML diagram that I made the other day. So, if you haven't seen the UML video, check that one out. My plan is to make roughly this piece here, the accounts. Um, we're going to talk through how inheritance works. So that's what I've got kind of up on the opposite screen here. So I'm going to start making some stuff first. So first things first, what I'm going to do is I'm just going to right click in here. I'm going to hit new. I'm going to hit Java class. The first Java class I'm going to make is the class for accounts. Yeah, that's fine. This will be a little weird because I've recorded this lecture and lost the sound, so it's going to ask me some stuff that you're probably not going to see on your end. So I've got my account there. Now I'm going to make another Java class. My next Java class is going to be for a savings account. We're going to go ahead and create that one. We're going to add that. We're going to go ahead and make another one. That's going to be a checking account. We're going to go ahead and create that. We'll add that. We're going to go ahead and make one last one, which is going to be for a high yield savings account. Okay. And then we're going to go ahead and we're going to populate some stuff. So I'm going to start by just making my account class kind of work here. So the way that I'm going to make my account class work is first things first, it's got to be an object, right? Or it's got to be a class. So I'm going to need some variables. I'm going to grab some variables that I have over here in the margin. So those are going to be these guys. So I've got a private integer for the pin. I've got a private double for the balance. I've got a public final string for the owner. What that means is that final keyword there, that's a modifier that means that we're never going to be able to change the owner of the account once it's assigned. That might be a bad idea, but I'm going to go with it. And then I've got a public string that's going to be type. Type's going to be just which kind of account is this. And so then our first thing that we're going to do is we're going to make a constructor. So I'm going to make a constructor called account. And that constructor is going to consist of getting, let's see, we're going to get a string called owner. And we're going to get a double called starting balance. Oops. Okay, great. So we've got our owner and our starting balance. We're going to need to attach those. So we're going to do this dot owner is owner. We're going to do balance is starting balance. Let's see. We're going to need to set the pin to something. So we're going to set the pin to the result of calling the set pin function here. So set pin's not written yet, so we're going to have to go write that set pin method at some point here. I'm going to make that a private method. It's going to be called set pin. Let's see. We need a return type. It's going to return nothing, and we're just going to leave this blank for right now. So we'll deal with that later. And then we're going to need one more thing, which is we're going to set the type of our account to account to start with. So this is just a generic account. What I'm doing is I'm saying, all right, accounts, be they checking, be they savings, be they high yield savings, be they some other weird thing, are all going to have some commonalities. This spot here is where I'm going to put all of the code that's in common between all of the account types. The advantage to having all of the code in one place is that if I were to write, say, a way to adjust the balance of an account, if I wrote that separately in the savings account class and separately in the checking account class, then what could happen is I could discover a bug in that method and then go in and change the way the savings account method works and forget that there is a separate way for the account balance to be adjusted in the checking account. And that bug could persist in the checking account. If I just put all of the code that they share into the account class, then there's only one place for me to go to modify shared code. And then it's automatically propagated through to what are called the children classes. This is good for workflows, it's good for security, it's good for bug fixes. So this is the way we want to try to organize things. Any code that's shared between a couple of classes probably is best in a parent class, and then each of those child classes can inherit from the parent class. They can have their own methods. That's totally fine. We're going to write some of their own methods here. But anything that's shared between them should really be in that parent class. So that's what I've got here. So let's sort out our setPen method real quick. For me, right now, all I'm going to do is I'm going to say the pin is 1, 2, 3, 4. That's all I'm going to write for setPen method. I'm going to add myself a little to-do here. I'm going to add a to-do that says write a real setPen method. So we should probably select some kind of random number, and then we'd like mail a piece of paper with that random number printed on it to the account holder and say, hey, here's your new pin. Great, fine. Then we'd need to set some kind of a hash in the account. That's all too complicated for the demonstration I want to have here today. So let's forget that, but know that that would be something we should be doing if we were doing a better job with this. Okay, so next thing next. I want to create an account and see that this actually works. Let's see. Oh, this says void, in fact, return. Oh, of course, I set a void method here. That means that I can't assign it. So what I want to do here is, instead of assigning it, I just want to call the setPin method. Just semantic issue. Well, logic issue. Sort it. Okay. So let's go back into our main class here, and let's create a test account. So I'm going to create an account called test account, and this is going to be a new account, and we need to create an owner. So my owner is going to be Joe. That's going to be my string, and we're going to do $123.45 as our starting balance. And then what we're going to do here is we're going to try to double check that that worked. So we're going to do system.out.println, and the thing we're going to try to print is our test account. Okay, now when we print out our test account, what's going to happen? Well, let's see. So when I press run on this, I'm going to get, well, that's not very freaking helpful. I got account, which is what kind of a thing is it, and an @ and some hash. That hash is basically the location of this thing in the memory. That is not very helpful to me. So what I want to do is I want to go into account and I want to write another method. I'm going to make this one public. And this is going to be a method that overrides something. So I'm going to do @override. And what the override keyword does is says to the compiler, hey, I'm expecting this to override a method that already exists. The method that already exists here is every object has a toString method. This is me overriding the default toString method. You saw the result of the toString method a second ago. This is the result of calling toString. I want a better way to do that. I want this to print in a prettier way, so I'm going to force it to print in a prettier way. And I just so happen to have a working version of that off over here in the margin. So I'm just going to go ahead and grab that. So all I'm doing is taking the owner and adding it to the string has a balance of, and adding the balance, and then adding in there, and then adding the checking account or savings account or whatever type it is, and then adding period. So we should be able to run our main file here and see better output. Great. That's looking like it's working. Now, thing is, I don't actually want there to be bare accounts. I only want there to be savings accounts, checking accounts, high yield savings account. This thing with the account is just about shared code. I don't want to actually use that. So what I'm going to do is I'm going to go in here and I'm going to say that this is going to be an abstract class. So what an abstract class means is that there will never be an account object created. There may be things that are accounts created. What I mean by that is I'm going to go ahead and in a second I'm going to make a savings account. But I don't want it to be possible to make a regular account. This one related problem thing is pointing here where I'm trying to make one. If I hover this, it's saying account is abstract, it can't be instantiated. You can't make one of those basically. So I'm going to comment this code out because we're not allowed to make accounts. They can't actually be made. What we're going to make instead is we're going to make specific kinds of accounts. So I'm going to go into my savings account class here, and I'm going to say my savings account class, it extends, which is just a way of saying it is a. So a savings account is a account. Okay. And then we're going to go in here, and we're going to need to, right now it's yelling at me about the constructor. So what that means is I need to write a way to construct a savings account. So same deal. A savings account is going to get some stuff. That stuff is going to need to include at least the same stuff as an account. So I just happen to have this typed over here, so I'm just going to grab it off camera, drop it in. So we've got an owner and a starting balance. And then we still need to, because it's an account, we need to create the account part of it. So the way you do that is with the keyword super. So super says, whatever this is extending, we're going to make a one of those. So I'm going to make an account. An account needs an owner and it needs a starting balance. So I'm just going to pass owner and starting balance straight to the super. And then we're going to talk now about how this is going to be different than a regular account. So the difference that I see is that a savings account should have an interest rate. So I'm going to give this thing a double that's going to be private. And this is going to be an interest rate. Oops, and interest rate. Okay, and then right here I'm going to set that interest rate. So for savings account, I'm just going to say they're all set at 1%. So set the savings account interest rate to 1%. Okay, then what? Well, then I need to also change the type of account. So this savings account right now, it thinks it's an account because super set the type. So super went into account and said, do this stuff. So it got a PIN, it got a balance, it got an owner, right? It also got called an account. So let's see that quick. Let's go in here and let's copy basically this code. We're going to uncomment that line. It's telling me that I can't make an account this way. So I'm going to make this a savings account that I'm going to call the test savings account. And it's going to be a new savings account. And it's got same balances. We're going to print out, and it's now called test savings account. So we're going to print that out. So we're going to hit run here. And we're going to get the same text that we saw before. That's because we haven't really changed anything, right? So this savings account also has an interest rate, but we're not displaying that anywhere. So I'm going to go into my savings account here, and I'm going to say, all right, in here, we need to at least change the type of account. So we're going to change the type of account here to, it is a savings account. So now if I hit run over here, we should see that Joe has a balance of 1, 2, 3, 4, 5 in there. Now savings account. Cool that? Let's go ahead and make a new thing. So a savings account has one thing that it can do that a regular account doesn't have, which is it can earn interest. So I'm going to go ahead and set I'm going to make a little function that's going to earn interest. So I'm going to say that this is a private function, and I'm going to call it earn interest. Okay. Now, earn interest needs a return type. So I think I have in my UML that should return nothing, because it's just going to change the balance of the account. And so what I'd like to do here is I'd like to say the balance is equal to, I should figure out what the interest is first. Yeah. Okay, so let's figure out what the interest is. So the interest is equal to the balance times the interest rate. Oops. Okay. Now, the problem here is interest doesn't exist. So I need to say, all right, that's going to be a double. And now it's saying here, balance is private. So this is kind of a thing that happens. In my process here, I made balance a private variable. I have two options here. I could swap private to something looser. We could make it public. That would probably be a very bad idea. We could make it protected. Protected would keep it to would keep modifiability to the class and the subclasses. Or we could just remove the access modifier altogether and just make it package private. I'm inclined to show you how to make a getter and a setter here. I'm actually just going to make a new method here that's not going to be either a getter or a setter. So I'm going to make a new method. My new method is going to be called adjust balance, right? So we're going to make that a protected method because I want the things in the package to have access to it. And this is going to be adjust balance. And it's going to take a double that's going to be amount. And what we're going to do is we're going to, we need a return type. This is going to return nothing. It's just going to actually do the thing and adjust the balance. And we're going to do balance plus equals adjustment. Plus equals amount. Okay. Now, we should probably do a little checking on ourselves here. We should maybe check that the account doesn't get made negative by this amount. And then throw some kind of an error if it does. I'm going to put in here just a quick to-do, and I'm not going to do that. So I'm going to put to-do, add some handling for if the balance were made negative. That's just me adding a note for something else I should do. I'm not going to do that in this video because that's not the point of this video. So we're just going to adjust our balance by the amount. Now I'm going to go in here, and I don't have access to the balance. So I probably do need to write a getBalance method. So I'm going to go ahead and put that in here. That's going to be a public method. Let's just call it getBalance. Got some autocomplete from the compiler here, or from the IDE here. That's great. So I've got my getBalance. Here I'm just going to call getBalance. So that's going to go ahead and grab my balance. And then we're going to multiply by the interest rate. That's going to give me an interest amount. And then we're going to do adjust balance. And we're going to adjust our balance by the interest. Okay. So this is a new thing that a savings account can do that a regular account can't. So a savings account can earn interest. A regular account cannot. So here we're going to go ahead and, let's go into main and just test that. So here I'm going to do our test savings account dot, and this is where we get to control what we can do here. So we're going to do earn interest. Did I spell earn interest wrong? So I made this method private. So okay. So in order for me to in order for me to call this method in the main class, I'm going to have to make this thing package private. So what we're going to do here is we're going to either swap this to protected or just remove it altogether. I'm going to swap it to protected because I think that's a good choice. So this is one of those things about access modifiers, right? You're going to be kind of constantly trying to make things work and deal with the appropriate levels of access. So let's hit run on this and see what happens. Okay. Why didn't it adjust the amount? I still have 123.45 in there. I think it probably did adjust the amount. I just didn't check on it afterwards. So let's take that print line and put it underneath here, and we'll try that again. So now we should get a balance before and a balance after. So as you can see here, I got that balance with 1% interest added. Great, that's working. Cool. So next, moving along, I'm going to make a checking account. So I'm going to go into my checking account, and I have some similar vibes here. So the first thing I'm going to do is I'm going to go into my savings account. I'm going to grab all of this stuff, and I'm going to paste it in here. And then I'm going to call this checking account now. So this is the constructor for my checking account. We're going to do our super is now not working. Interest rates don't exist for checking accounts. Type does. That should be checking account. And we still have a problem. So why is this thing red? It's saying it expected no arguments but found 2. What's up with that? Well, right now you might notice it's trying to call object. It's saying checking account extends object, but checking account is supposed to extend account. So I forgot to put the word extends here. And so it thinks that it's only extending object by default. Every class in Java extends object, which is like the base. Java says everything is made out of object. So here we're going to need to extend our account. Okay, so that's working there. I'm going to need in my account here, in my checking account, I'm going to need one new variable. I'm looking at my UML in the opposite corner here, and that's going to be a public integer. Actually, you know what? This doesn't need to be public. Let's just make it a private integer. And our private integer is going to be last check number. So this is kind of an artifact to checks back in the day. Checks have a number on them, which says like which check out of this account is this. So they would start at like 1,000 or so and go up. And this is used to make sure that we're that it's a kind of anti-fraud measure and an accounting measure. So you can you used to go through your checking account and be like, oh, check 1023 was $7 for something. Check 1024. Oh, I don't see that one. I don't know where that one went. That check 1024 might represent money that you don't know is missing from your account, yada yada. If you've ever heard somebody say that they balanced a checkbook, that's what they meant. It's you go through and you tally up all the checks that you've put into the account or taken out of the account, and that gives you the new balance on the account. Ain't nobody does that shit anymore. It's a waste of time. So, whatever. Point is, checks have a number, and we need to keep track of that number for when we order more checks. So that's the next thing we're going to do. We're going to add a order checks function here, or an order checks method, really. So we're going to add an order checks method here, and that order checks method is going to, let's see, that's going to be a private method. We're going to make it private. Actually, you know what the hell? Let's make it a protected method. Oops, that's not what I want. I don't want to override the adjust balance method. So let's dump that and make protected. And the this is going to be a void method, and it's going to be called order checks. And we're going to need to adjust a couple of things. So our first thing we're going to need to do is we're going to need to say how much do checks cost. So I'm going to say that checks cost 50 bucks. We're going to deduct 50 bucks from the balance of the account. So we're going to do, let's see, how do we adjust the balance? We do adjust balance, and we're going to put a negative 50 in there. So we're going to subtract $50 from the amount in the account. Why can we do that? So remember, adjust balance method was a protected method in the account class, and because a checking account is a subclass of the account class, it has access to the protected methods. So we've got our adjust balance method that we're calling, so that's subtracting 50 bucks. And then our next thing we're going to do is we're going to do some kind of order check process. So I'm just going to do system.out.println ordering checks. And keep in mind that this is a stand-in for a much bigger thing, right? That print line is just saying, hey, we're ordering some checks, yada, yada. Remember, that's probably going to be a much more involved process, right? We need to send an order to the printer, and then we need to have those packaged and then mailed, and that's probably mostly an automated process. So, like, there's going to be more stuff there. But for right now, I'm just saying we're ordering checks. And then what we're going to need to do is we're going to need to increase the last check issued number. So we're going to do last check number plus equals, and let's say it's 100 checks for 50 bucks. That's probably not realistic, but whatevs. Okay, so we increased this so that the next time they order checks, they'll start at, like, if we started at 1,000, we'll start at 1,100 next. You guys might notice I have a logic error in here right now. So let's go to main, and we'll make a little bit of testing. And while I'm making testing, you can think about what that error is. So let's see. I need to swap these for checking. And search and replace would be a great way to do this. Whoops, I ended up with too many of the word test in here. Okay, so I got my test checking account going. We're going to need somebody else for that, so let's put that under Bill's name, and that one will do 45.67, I guess would be the right number. Actually, let's go ahead and give Bill 345.67 so we don't accidentally make his account negative when we order checks. All right, now we've got a little issue here. It's not a test checking account object, it's a checking account object. Now, when we hover this, we've got, it's supposed to be a savings account, and I'm making a checking account. That's here. So I need to say checking account. So we're making a new checking account called test checking account. That's a new checking account with these properties. Okay, so now here, this is calling our test savings account. That's not what we want. We want that to be our test checking account. And now we're running into a earn interest problem. So remember, the checking account doesn't have an earn interest function. An account doesn't have an earn interest function. A savings account has an earn interest function, and a checking account is not a savings account. They're both kinds of account, but a checking account isn't a savings account, so it doesn't have an earn interest function. Or, damn it, it doesn't have an earn interest method. And so I need to remove this. What methods can I use on my test checking account? Well, I can use order checks. So let's call the order checks method on this and see if it works. So we should get, Bill has balance of $345.67 in their checking account. They order some checks, and then they have a balance of $295.67. So we used the order checks method in the checking account class on our test checking account. And as a part of that process, we used the adjust balance method in the account class to change the balance of our checking account. And our checking account knows how to use the adjust balance method because the checking account is an account, and accounts know how to adjust their balance. Hopefully that made sense. Okay, last thing last, let's make a high yield savings account. So I'm going to go into high yield savings account, and I'm going to need a constructor here. So I'm going to go off to the side here. I happen to have written this already. So I'm just going to grab this. I'm going to drop it in right here. And the only difference is that a high yield savings account is going to have an interest rate that's a bit higher. So here I'm calling super. The problem, the issue that it's raising right now is that I'm calling object right now. The reason for that is that I haven't yet told this that it extends anything. So we need to tell it extends something. And because it's a high yield checking account or a high yield savings account, it's going to extend a savings account. Savings account itself extends account. So I've got this diagram, right, to bring my UML diagram back into play, right? I've got a high yield savings account extends a savings account, and that savings account extends an account. So a high yield savings account is an account, but it's also a savings account. So I have that structure here. So this is called multi-level inheritance, where we have our high yield savings account is extending our savings account, is extending the account, is extending the object class. So we also have here an example of hierarchical inheritance, which is our account class is the parent to both the savings account class and the checking account class. All right, so I've got my kind of multi-level inheritance with my like multiple children here. There's only one thing that I want to change about a high yield savings account, which is I want it to get 3.9% interest. So that's all I'm going to do here. I'm going to say we're going to set our interest rate to 0.039, and we're going to hit semicolon here, and we're going to see that this is a private access item, right? So we've got a couple options. So we can either go into our savings account and make our interest rate protected. That would be an option. We could add a setter method to this. That would also be an option. I'm going to go with that one. So I'm going to make a protected method here that's going to be called set interest rate. And all this is going to do is it's going to take the interest rate and it's going to set it equal to this new interest rate. So I'm going to do this dot interest rate is equal to interest rate. And interest rate right now isn't meaningful. I'm going to need to pass that along as an argument. So we're going to tell this to expect an interest rate. And that's going to need to be a double. And then here I've got a problem, which is that I didn't set a return type here. So my return type for setting an interest rate is going to be void. We don't need to get anything back from that. We're just going to go ahead and set that interest rate. So this is a place where you could use some kind of checkers, right? So we could do like if interest rate is let's see, if interest rate is less than 0, we could cause some issues. If interest rate is bigger than 0, we can go ahead and do this. So let's do if interest rate is bigger than 0 and interest rate is less than 1. We probably can't have an account with anything outside of that. So if it's in those, we'll go ahead and set it. And otherwise, we'll make some kind of a stink. So maybe let's do throw new Let's see, that's probably going to be an illegal argument exception, and that's going to be something like, that's not a valid interest rate. Right, this is why you use setters instead of just assignments, right? So you can do some kind of checking before you do that assignment. This is the kind of power of setters. Okay, so I've got my set interest rate method here. Now I'm going to go back into my high yield savings account, and instead of just declaring the interest rate, right, we're going to call set interest rate, and we're going to call that on 0.039. Okay, now we're going to go back into main. We're going to grab our savings account stuff. We're going to paste that down here, and we're going to call this a high yield savings account. Okay, and I have one issue here, which is that this thing is in fact just a new account. So I like the name Xavier, so we're going to put that in here. And this can get some amount, so let's do $234.56. Okay, now what's the issue with this? Right now, if I hit run on this, I'm going to see Xavier is earning $2 in interest, which is 1%-ish. And the issue is here I put the word HY, or the letters HY, into my test, but I never actually made this a high yield savings account. Right now this is all still a bog standard savings account. So I need to say I want a high yield savings account, and here it's going to yell at me that I can't. Oh, here it's not going to yell at me that I can't store that in here. The reason it's not going to yell at me that I can't store that in here is that a high yield savings account is a savings account, so you can store it in here. I wouldn't recommend doing that unless you have a pretty good reason for it. We're going to go over some good reasons for it in a couple of days. For right now, I'm just going to go ahead and change it to a high yield savings account. Worth noting that you can store a child element into a parent element field. That's essentially saying what this is doing is this is blowing a hole, this is setting aside space in the memory to store a high yield savings account. And since a savings account, or since a high yield savings account is a savings account, if I set aside space for a savings account, I can store a high yield savings account there as well. So let's hit run on this and just see that we're getting 4% interest for Xavier. Cool. That's $10. That's more reasonable. All right. So I think what I have here is basically working. Thank you guys for watching. I know this has been a longer video. I really appreciate the attention span that went into watching this. Thank you much. Go forth and use your new powers for good rather than evil.